Good afternoon, everyone. My name is Alicia Capello. I'm going to be your moderator for this session. And before we begin today's presentation, there's a few reminders that we have for you. The first is that we do have a code of conduct for the conference that we will be adhering to. I'm going to post a link to that code of conduct in the chat, as well as the general email address for the conference that you can send a note to if you have any questions about that code of conduct, or if you have any questions about the conference in general or any issues that have come up. You'll notice that you are all muted. However, you can put any questions you have throughout the presentation in the chat. You can put it in the Q&A window if you want, or you can raise your hand and we'll be able to unmute you so you can ask your question out loud and live. All of those will work for us. The session is being recorded and the recording has already begun. And if you'd like to enable captions, you just have to click the Show Captions button at the bottom of the screen, and that will enable it for your view only. And so I think that's it for the reminders, and we're ready to get going. So today's presentation is computational thinking with a little help using GenAI to assist in coding for technical services, and it is presented by Kevin Burke. So Kevin is the metadata analyst at Carleton University in Ottawa, Canada, which is only an hour and a half from where I'm sitting right now, which is awesome. His work focuses on the batch remediation of legacy data, inclusive description, and music cataloging. So I will let you take it away, Kevin.
Awesome. Thank you, Alicia. Let me just get my slides up here. Right. Just gonna hide my own face because it's always distracting. All right, well, thank you everyone for coming, and thank you, Alicia, for the introduction. So as Alicia mentioned, today's session, I'm going to be talking about my work using generative AI to assist in coding for my role in technical services. I want to start today, though, with a land acknowledgement. I think this is especially important for online events because we're all joining from so many different places. So I'm joining today from the unceded territory of the Algonquin Anishinaabe Nation in what is currently known as Ottawa, Canada. I'm a settler on this territory, and I have family roots in the United Kingdom and Ireland. I've had the privilege to live and work on this territory as an uninvited guest, as well as on the unceded lands of the Musqueam, Squamish, Tsleil-Waututh, and Mi'kmaq. And for those who are familiar, you may recognize those names as being on both the west and the east coasts. So I've done kind of all over, all over this country. So for today's presentation, I'm going to try to give a bit of an introduction and some context to my work. I'm going to talk about some of the issues and the challenges that I encountered in it, some of the strategies I found useful in overcoming some of those challenges, the benefits and the outcomes, and I'm going to do my very best to leave time for questions. When I practiced this, I was right on time, and we'll see how fast I talk today, so we may have more time than we think. This presentation, I just want to say, is going to be rooted in my own experience working as a novice coder and using generative AI for this task. I'm going to have a blend of references to kind of news media, scholarly sources, and a lot of anecdotal evidence. I will say this isn't a comprehensive research study. There's no lit review, really. I didn't run any experiments. This is more of kind of loose exploration of these concepts. So as a bit of a personal introduction, hi, I'm Kevin Burke. My pronouns are he, him, and I've been the metadata analyst here at Carleton since July of 2024. Prior to this, I was the creative arts librarian at Mount Allison University in Sackville, New Brunswick. My academic background is in music, which I say to drive home the point that I don't have a background in computer science or programming or coding or anything. About the most coding I did before this role was learning some HTML for my MSN days. Millennials will remember. My focus in this role is primarily on large-scale analysis and batch remediation, especially of legacy records. So how did this work start for me? Shortly after I started here at Carleton, we began a batch remediation project that focused on around 100,000 legacy records. Carleton was an early adopter of digital cataloging, and so we kind of built our own system back in the 80s or 90s, I forget exactly when, And we ended up developing a lot of local practice for that homebrew system that kind of stuck around through several migrations. And we've been left now with a number of records that just don't meet our current standards. Basically, with these 100,000 records, our first phase of this was to retrieve updated versions from WorldCat using existing OCLC numbers from those records. Doing this, we were able to pull in about 50,000 records, but we needed to confirm that they were actually matches to the records that we already had. And obviously, ideally, we could do this manually and compare each pair of records, but with 50,000, that was just way too much. We'd, still be doing it. So I knew I needed to find a way to flag those low quality matches, the ones that really needed manual review, and overall just reduce the amount of manual processing and comparison that we had to do. I ended up turning to generative AI to fill this knowledge gap. Solving this problem involved a very particular approach to problem solving, which is computational thinking. So computational thinking, from the title of the presentation, is an approach to problem solving that's focused on decomposing problems into discrete steps. So we often think of it in terms of computer science and programming, but it's not actually unique to that field. It's something that's been around for a very long time. But basically, the idea is to take a complex problem, break it down into discrete steps, and develop unambiguous ways to progress through the solution to reach your end goal. This can be a really counterintuitive way of thinking for people who don't have a background in logic and computer science in kind of that environment. So I ended up using AI a lot to help lower the kind of barrier to entry to this and the challenges that it posed. This did come with its own problems, though. AI poses a number of problems, and they kind of break down into practical issues, technical issues, and then also ethical issues. So getting into some of the issues. On the most basic side are the technical issues. I did run into a lot of issues with AI models that would get stuck in loops. So a lot of the time I would prompt it and I would say, I need data moved from this format to this format, and it would return some code that didn't work. And I would say, that code isn't working, please revise it and try again. And it would return exactly the same code along with a message saying, oh, sure, here's the revised code. Anybody who's done a lot of work with AI will be familiar with this. It's quite a frustrating problem. It's rooted in the lack of understanding that these models have, because they don't truly understand the response. They're generating a statistically likely response, but they do tend to fall into this kind of false confidence. And so it would present this code as revised when actually character for character, it was exactly identical. A similar kind of related issue was these models tending to make non-functional changes. So it may produce a snippet of code that looked better, but the changes weren't actually in functional sections of the code. So often it would put a change in a comment line, which is a line that just doesn't run at all. Or it might rename a variable, but not actually change how the data stored in that variable was being handled. So these issues were quite frustrating and quite common, but they aren't that difficult to address. You really see them as soon as they happen. What's a little more insidious is the issue with semantic errors. So for those unfamiliar, a semantic error is an error in code that doesn't necessarily stop it from running, but prevents it from running in the intended way. So these are things where the code is functional, but it may not be acting the way that you intended it to, and it may not return the results you expect, but it will still return results. So it can be quite difficult to spot. Especially as a novice coder, it's really difficult to understand the structure behind code and how data are being handled. And so semantic errors can be quite difficult for inexperienced coders in particular to spot. The source of semantic errors could be the user and it could be the model. Either way, it's up to the user really to find them. So one example of this is early on in my work, I accidentally wrote a section of code to use the 254 field of the mark record, the musical presentation statement, instead of the 250, the addition statement. That was my mistake. But because I didn't catch it, it stayed in the code for quite some time and meant that when I did finally notice, because I was receiving some outputs that weren't what I expected, I had to go back and make a lot of changes because of one little error that persisted. So with these errors, they may not break the process fully, but they can make it a lot less efficient and a lot less effective. And that's how we get into kind of the bigger side of this, which is suboptimal designs. So again, this can be sourced from either the user or the AI system. It can include things like unnecessary and redundant steps, excessive processing of data, excessive use of libraries, which are kind of pre-made code packages you can install and use in your own code. And things like that, where your code kind of is not as refined, as elegant, or as efficient as it could be. This can stem from our own limitations and from the limitations of systems. So I have, when all you have is a hammer, because as a novice coder, I was really using this to learn Python primarily. So Python was my kind of go-to tool, and I used it for every task, even when there were maybe other options that were better. So one thing I tried to use it for was extracting data from particular fields of MARC records to build into queries for Z3950. And I spent days working on this with Python, trying to make it so I could get just the data I needed, extract it from this particular subfield, but get all the versions of that subfield. It was a whole thing. And it turned out after several days of this, I picked up a book and realized, oh, this task would be absolutely trivial if I were using XSLT. So when all you have is Python, every problem looks like it can be solved by it. But sometimes we need to kind of go beyond those limitations and embrace other methods of addressing problems. Now, when this suboptimal design is taken to the extreme, that's when we get one of my favorite technical coding terms, which is a big ball of mud. So this is a technical coding term, even if it doesn't sound like it. A big ball of mud is a haphazardly structured, sprawling, sloppy, duct tape and baling wire spaghetti code jungle. So essentially, this is code where it's functional, but I call it inscrutable. This is code that lacks a coherent architecture. It doesn't have an overarching structure that makes it clear what this code does. And so this prevents users and programmers from really understanding the code easily. And it makes it very difficult to spot errors and spot inefficiencies because the code has just kind of been thrown together. This makes repairing the code much more difficult. It means that a lot of repairs need to be done piecemeal. So instead of looking at the overall structure of code, finding those spots where errors could crop up and addressing them in a targeted fashion, you end up kind of fixing problems as they appear, making small changes throughout the code in ways that contributes to the mess of this architecture. So not only does it start in a bad place, the more you work with it, the worse it gets. This may not be much of an issue when we're dealing with really simple tasks and short-term fixes, but it does really negatively impact the longevity of the code and the efficiency as well. So, if you have one file that you just need to do a simple transformation on, it doesn't really matter if the process is super efficient, you're going to use it once and throw it away. But for something like what I was working on, where we knew that we wanted to compare large numbers of records, we knew that it was something we were going to need to do several times throughout the process. And so having code without a sensible architecture was a serious liability. Another example of this, we developed some code that let us display two MARC records side by side so we could manually compare them. So we used that for comparing these kind of like low confidence matches. And that code was very messy. And we actually had a placement student join us who had a background in coding with Python. And so I showed her the code so she could help us improve it. She took it, she went away for about half an hour, came back and said to me, I'm not sure what you're trying to do with this code. And so we ended up having to sit down and really try and puzzle out why the code was built in the way that it was. Try and figure out what kind of architecture would be most effective for this use case. And in her work trying to revise this code, she ended up basically rebuilding it from scratch. So what we had was a piece of code that was functional. It did mostly what we needed it to do, but it meant that maintaining it, improving it, and using it in the future was a huge issue, and that lack of structure became a real liability. On a related note with these technical issues, we also run into issues with scalability and replicability. So when we have this inefficient design, it might not matter much when we're working with really small data sets. So, if I'm only trying to process 50 records, it doesn't really matter if the code is inefficient. It's still going to run pretty quickly. When I get into 80,000 records or 120,000 records, these inefficiencies can really slow things down and make the process much less efficient and waste a whole lot of time. The replicability side of things matters both in terms of being able to reproduce the results from the AI systems. So with the inherent variability of generative AI, each session can take a slightly different course. And that means that I may build a piece of code in one session, return to work on it in another, and end up taking it in a different direction. It can be really difficult to get that kind of consistency that would enable us to build stronger plans long term. Replicability is also an issue in terms of being able to share code and data sets with other people and have them get similar results as well. So we end up with this code that is functional, but barely. It sometimes runs into issues with larger data sets, and it's not always shareable, even within our own contexts. And now I want to take what I'm calling a brief stroll through ethics. I will fully admit, originally this was one slide, but after the panel discussion on Monday from Sarah Appidu, Emily Tserenner, Andrea Baer, and Violet Fox, I was inspired to kind of flesh this out a little bit more. I will say that it's not going to be a full exploration, so I don't have a lot of answers, but I do want to take this time to try and raise some questions around my use of this technology. I want to recognize that others have and will still address this much more eloquently than I'm able to, but that I think it's kind of beholden on us to acknowledge these issues and try and address them where possible. So in doing this, I've tried to divide the ethical issues into kind of what I'm calling lower stakes risks and high stakes risks. This might be a bit of a losing game because it's all a risk in a way. But these three are the risks where I see fewer or less serious sources of potential harm. So the first one I want to talk about is privacy concerns. We know that privacy is a major concern with generative AI in terms of feeding it personally identifiable information. While that's not really an issue in this case, where we're using it to generate code, there are still some situations where we could accidentally feed these models what should be confidential information. So things like API keys, login information, authentication information, that can all be included in code. And so it's very important that we're aware of what kind of confidential information we're handling and ensure that we're not accidentally contributing to privacy violations. Similarly, these systems are biased, which again, in this case, is slightly less risky than in some other use cases. In terms of bias, what we're often thinking of is when AI is making decisions or when people are dealing directly with AI, we run across these biases of representation and allocation where the ways that generative AI represents certain populations can be biased, or the ways that it influences decision-making for policy can be hugely problematic. Again, we're not making decisions that are necessarily directly impacting people here. So in this use case, the bias is less of an issue, but it's still important to be aware that it is present within these systems. I also want to talk a little bit about AI slop. This is a term that's more often used in terms of media online, especially images on Facebook. If people have seen Shrimp Jesus, that's an example of AI slop. Basically, it's the idea that the more content AI generates, the more it kind of floods our information ecosystem, and the lower the quality of our overall information sources becomes. In terms of code, this can be significant because we are churning out this code without necessarily a solid understanding of it. And it means that we can end up sharing code that doesn't necessarily do what we expect and may include, excuse me, security vulnerabilities for more complex tasks, or even just inefficiencies and unnecessary code. Basically, we just need to be aware of our responsibilities when we're using generative AI in terms of authorship, and make sure that we only share what we can personally vouch for, and be explicit about our use of the technologies to address this risk of proliferation and sharing of slop. Moving into some of the high stakes risks for this use case. So the first one is intellectual property. One thing that I really want to address is the idea that there's not necessarily always an agreement between fair use in a legal sense and fair use in a moral and non-legal sense. And so, well, the legality of a lot of this extractive training data process that a lot of AI companies use is still up in the air. I think it's also important to recognize that no matter where the law falls on this, there is still the moral aspect as well. And part of that goes back to the idea of attribution. Because we can't give attribution to the creators of training data because their authorship is obscured, it's a lot of our use of their information is kind of questionable, and the bulk harvesting of content really strips authors of their agency and how their creative works are employed. And then in terms of the environmental impacts, there was a fantastic session on this yesterday, but I want to stress that it goes beyond kind of the water, power, greenhouse gas emissions that we often think of, also into this idea of land and ideas of land ownership and the allocation of resources. In the Canadian context, we see that it's really rooted in these colonial and extractive views of land and natural resources. There's a project proposed by Kevin O'Leary of Shark Tank infamy, the worst Kevin, who proposes building data centers on Treaty 8 land in Alberta. And this is highly controversial because they have not yet consulted with Indigenous nations in that area, which they say they aren't legally required to yet. But this is really kind of reinforcing those colonial ideas of land as a place to extract value. And we see it accelerating in some ways with this greater environmental impact, and a reluctance to actually change how we view land. It's kind of like colonialism 2.0. There's also a massive infrastructure required for all of this work. Crawford and Yoler back in 2018 mapped the global infrastructure and life cycle of the Amazon Echo Dot. And they decided to look at it in terms of three axes, which were the material resources required to produce and support and dispose of this technology, the data required to train it and to support its continued use, and the labor that comes in at every stage in the process, from resource extraction to use to continued training of AI models to disposal. Now, Crawford did publish a book about this, which I have not read yet, but I've heard really great things. So if anybody wants to throw something about the book in the chat, you are more than welcome to. And then the last area that I really want to talk about in terms of the ethical concerns I have around this work is labor practices. So as we know, labor is in an unstable state with the proliferation of AI technologies. We heard on Monday in the keynote address from Nick Tanzi that 1 out of every 4 jobs are exposed to AI. I did some digging. I found this in an International Labor Organization report, which is a United Nations agency. The idea is that 1 in every 4 jobs are exposed to either transformation or partial automation via AI based on the complexity of the tasks and the repetitiveness of the tasks involved. And of course, one of the things that we see is that work that is done more frequently by women is often more exposed. So we're already seeing kind of inequities in the impacts of these technologies moving forward. But also in terms of labor practices, inherent in the use of these systems is an implicit acceptance of the labor practices of the companies that provide them. So we know that no system can exist without human labor. This can be everything from resource extraction, infrastructure, production, to content moderation, and every step of the process. A really great example of this is OpenAI hiring content moderators in Kenya, which is a common practice for social media companies, paying them less than $2 a day and providing inadequate mental health supports for people who are dealing with some truly traumatizing content, as a way of tailoring the outputs of these systems to avoid harmful content, for end users. The other side of the labor practice element is on our end as well. So when we use these technologies, I think we need to be aware, are we trying to replace human expertise and labor, or are we trying to enhance that? And are we able to reconcile our use of this technology with our own desires for proper compensation and respect for our labor and our expertise, which in the library field is under attack more than ever? And especially in our current budget crisis that everybody is feeling in some way or another, I think it's important to ask, does our use of this technology support and empower our workers, or is it devaluing our work? Is this efficiency actually saving us time and allowing us to produce better outputs, or is it justifying our the scarcity that we face? Now, I don't have an answer for a lot of this, but one thing that I do think is important is working to minimize reliance on the technology. So what I've tried to do with this approach is develop an approach where the focus is on developing skills and minimizing reliance. My goal is to improve my capacity for doing this work in the future, enable myself to have better oversight and insight into the processes that I'm running, and enable easier repair and revision of these processes as I move forward. So when I started and I was brand new to coding, I had to rely on AI a lot to fill all of those knowledge gaps. But as I learn more, I'm able to reduce that reliance and become more self-sufficient and more discerning in my use of the tool. Basically, it's this need to find a balance between supporting personal growth and professional growth and meeting operational demands that requires us to balance those uses of AI with less resource-intensive approaches that we may be more familiar with. So having been a bit of a downer, I do want to talk about some of the strategies I used and how I found them, how I found they made my work more efficient and more effective. As a bit of a side note, I do want to say why I don't endorse vibe coding and why I didn't use it in this process. So vibe coding is a relatively recent term in the lexicon. It refers to a coding process where the user doesn't handle the code. The user works in natural language and AI models produce the code and do all the revisions. The reason that I personally didn't follow this model and why I don't think it's appropriate in this context is because my key desire is to maintain that human oversight and the human-driven process while developing those skills so that I'm able to be more self-sufficient in the future. Because I wanted longer-term stability and usefulness from my code, and because I wanted just a better comprehensive understanding of the process itself, I rejected vibe coding as being kind of antithetical to my goals. And so I decided to go with a more hands-on approach. And so these are some of the strategies that I found useful in the approach I did decide to take. So the first is prompt engineering. For me, this meant planning and drafting prompts in a text editor before submitting them to AI models. Definitely worth considering prompting strategies such as the CLEAR approach from Leo Lowe, which stands for concise, logical, explicit, adaptive, and reflective. Basically, when you're prompting for coding, you need to be very specific So you need to be explicit about what inputs are available. You need to be explicit about what type of outputs you expect to receive. And you need to be explicit about any restrictions you have on the code, such as mechanical restrictions from your machine or maybe languages that you need to work in. This will help you get better results from the start and will help prevent some of those errors that I mentioned earlier, the semantic errors, from cropping up in the process. Another useful tool is being able to set limits on your conversation with the AI model. So this can include things like limiting the programming language. So I often said I was only going to use Python because that was what I was learning. I wasn't going to start dabbling in C or anything like that. Limiting what modules or libraries are available to the AI model, being very specific about the input and output, etc. But it can also mean things like limiting the tone and the complexity of responses. As a novice coder, this is very useful to be able to say, please identify the errors, but explain in plain language for a novice coder, because it makes the information a lot more accessible. You can also create scenarios. So things like you are an experienced programmer helping a junior colleague, blah, 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 which can help give the conversation a bit of a more organic flow. You can also do fun scenarios like you're a wizard helping your apprentice, which is really great for reducing frustration and fatigue in the process. So I have just some samples of prompts that I used in a recent conversation. You'll see that I've underlined sentences in the first prompt. So the green sentence, I'm setting up a scenario. In the orange sentence, I'm providing some context for the model of the problem that I'm working with. And in the pink sentence, I specify the tone by saying I want straightforward questions. And I'm specifying the desired output, saying you need to help me troubleshoot by asking these questions. And then further on, you'll see that in response to the questions, I get very concise, unambiguous responses. Another approach is pair programming. So this is a kind of form that the conversation can take. So in terms of traditional pair programming, we're looking at two programmers who work together. One is the driver, one is the observer. The driver is the one who's writing and implementing the code. The observer is checking it as the driver writes it for errors and is also recommending alternative strategies. The two users will switch roles periodically, and it's been found that this improves both performance and efficiency in coding, as well as creating professional development opportunities and opportunities for sharing knowledge between programmers. Now, obviously, this requires two participants with agency. So working with AI is a little bit different, but you can follow a similar model. So you can set it up and say, I'm the driver, you're the observer, but it's often hard to have those firm boundaries. And what I found was that the role switching happens a lot more organically. And ultimately, the user is the one who's responsible for checking the code and for driving the session because the AI is only responding to your prompts. My slides won't advance. There we go. Working iteratively is obviously a must. Any kind of decomposition task is going to involve working iteratively. So a complex task requires that we break it down further and further until we reach the simplest steps possible where we can address them in an unambiguous way. And AI can be very helpful for the kind of thought process involved in this. So it involves kind of breaking things down as small as possible. I often would focus on a single line of code or a single function at a time and expand out from that. But then also when the code was more complete, going back over it and finding those inefficiencies, finding ways to improve the overall process and simplify it was very important for building a truly functional piece of code. I also found it very important to debug manually, not only because AI isn't always the best at debugging, but also because it really helped me develop my understanding of the code and my own skills as a programmer. So doing things like using error messages from the terminal or warnings from a development environment or code editor, and troubleshooting with online resources, those more traditional ones like Stack Overflow posts, which are, hit or miss, and library or module documentation and specifications, was really great as a way for me to develop my own skills and my own understanding of these processes. And a great way of doing this was for me to create a planned input and make sure that the output I got at the end was as expected, so I could check for those semantic errors. And finally, the key part for me was combining it with traditional learning. So this involved taking programming and computer science courses, reading online resources like Python for Everybody, W3C Schools, Stack Overflow, etc., reading the documentation for the modules and the coding that I was using, and really augmenting that work with AI so I could develop my own skills, reduce my dependency, and still kind of deliver on those project outcomes. In terms of the outcomes, and I'm going to blast through this so we have time for questions. Obviously, the biggest one was the project success. We were able to finish the first phase of our batch remediation project, which was bringing in those updated versions of records from WorldCat in around 4 months. Through this process, I was able to update over 48,000 records and add over 300,000 subject headings to our catalog. Of those 48,000 records, about half of them were new to our consortial catalog as well. So that was 24,000 resources that are now available in the discovery layers of 19 university libraries in Ontario. This cleared almost half of our legacy backlog. So we have just about 52,000 records left now that require update. And I've been able to use this same strategy for a lot of other tasks for smaller projects, including creating XSLT to convert authorities from SCOS RDF into Mark XML, writing macros for Excel, structuring queries in Polish notation. Anyone who doesn't have a background in logic will be able to tell you how terrifying Polish notation can be. And so this strategy has been very helpful for kind of making that work efficient and possible. The flip side of this is the skill development and the professional development. So I was able to develop my own skills while still producing these outputs and building on these projects, to the point that I was actually able to rewrite the first script I ever used AI to build completely manually. And I was able to take the process, streamline it, and simplify the inputs. So it's a much neater process now, and I didn't need to rely on AI to do that work for me anymore. And so I've been able to use my own coding skills now for doing things like extracting data from MARC records, writing normalization rules, and other kind of simple coding tasks that prior to this work were beyond my capabilities. And finally, the other major benefit I see is the capacity to lower barriers. So programming has a very high barrier to entry for people who don't necessarily have the background in it. I can speak from experience that it's quite intimidating to start. And so the ability to produce outputs while building those skills and not have to say, sorry, this project needs to wait 6 months while I learn Python was a huge boon for me in this work. Studies have found that using generative AI as a novice coder also provides significant benefits to programming performance, mental workload, and effort, but also that continuing to use the tools in this way improves that even more. And so we become more efficient in using the tools the more experience we have. So it really has this potential to make coding more accessible for non-coders, which in technical services is always a benefit. And so in conclusion, we see a lot of promising results from this. It's obviously not a perfect technology, and there's a lot of things that we need to consider in terms of our use of the tools. But I do think it is quite exciting, the potential that they have, and there's a lot of potential there for us. I do have some possible avenues for further inquiry, but I think we can kind of skip over those. Basically, it's just more study of this particular context and broader contexts as well. And with that, I will say thank you and take some time for questions. On this slide, there is my email and my GitHub. On GitHub, I share code that I've used in these projects, but I will say that I only share it after I've been able to revise it manually as part of my commitment to reducing AI slop. I don't share anything that was written with AI without revision, and I'm always careful to explain where I used AI and for what. So with that, I'll stop sharing. And we have just a little time for questions. Woo!
Awesome. Kevin, thank you. We don't have any questions in the Q&A box yet, and I asked a question in the chat because we saw your one slide that had the screenshot of Copilot, but I was curious what other Gen AI tools you used and if
Right.
one of them was more helpful than another one.
Yes, actually. So this I did mention in my kind of other avenues for exploration that I skipped. So I originally started with Copilot. Like many of you, my institution has an institutional license for Copilot. Copilot has Microsoft's built-in enterprise data protection, which is um, maybe not as nice as they make it sound, but I know a lot of us are kind of pushed to use Copilot for that reason. I found though that Copilot wasn't giving me great results, so I did eventually switch to Meta AI. I'm not exactly sure why I got better results from Meta AI. I suspect it's because it integrates Meta's Llama model, which is built specifically for coding. That being said, there are tools specifically for coding with generative AI, such as GitHub Copilot or Cursor. One issue that I found was that some of those tools actually have their own kind of barrier to entry in terms of skill. Um, and so early in the project, I found a small generative AI or small AI model from California Digital Libraries called Mark AI that they use for deduplicating Hothy Trust. And it sounded perfect. It was exactly what we were looking for, something that could take MARC records and look for similarities. But the technical skill required to implement it was just beyond my capabilities at that point. So there is kind of this balance that we have to hit between what tools are really best for the job and what tools are accessible and usable for people with certain expertise.
Awesome. Um, there's a couple of comments in the chat, but if anybody had any questions, feel free to post them or raise your hand and we can unmute you.
But yes, and I see a comment about getting stuck in loops. Yeah, and unfortunately, I don't have a good solution for it. I've been asked this in other places too, is what do you do when you get stuck in a loop? I usually restart. I start a new session, rewrite my prompt, and just kind of go back to square one. We've got a
Um,
hand up.
Yep. Just there's a question in the chat about the slides. So if Kevin is willing to share his slides, we can get them posted on the main Gale website underneath the description for this particular presentation. So you can look there.
Oh, yes.
And
And I
uh,
think they might be under the resources tab.
yes,
I
under the
tried to
resource.
load
If
them,
you've
but I'm
already
not sure they made
posted
it.
them, that's awesome. But if you haven't, yeah, they will eventually, if they're not there right now, we can get them up there.
Yeah, I don't see them, so we'll get them up.
Um, Shamara has a question.
Hi, can you hear me?
Yep.
Yes.
Okay. Shamara McCray, I'm from Florida State University College of Law Library in Tallahassee, Florida. I had a question regarding the tools for coding. I primarily handle like serials cataloging, so we're talking subscriptions. I'm wondering if there is a particular AI tool that assists with subscriptions. Because I know like a lot of times I'm having to put in if it's like an annual subscription, monthly, weekly, daily type of subscription. So a lot of this is autonomous anyway. So I'm just wondering if there's a tool that actually assist with that, or maybe if OCLC or something may already have some kind of tool that's out there available for that.
I'm not familiar with any AI tools specifically for like serials cataloging. I don't do serials here, so it's a little bit outside of my wheelhouse. I know that we're an ALMA library, and ALMA has their
Mhm,
serials prediction patterns, which I
mhm.
think lets you create kind of stub records to be reused for that process.
Correct.
Um,
And that's the
but
thing, because I know that we're the ones who's primarily has to manually input that information. And
mm,
sometimes we may have some difficult subscription patterns, if you would, like something may be irregular. A subscription that we may get 1 year, we may not see another one for 3 years and another one for 5 years. So it's not repetitive, kind of thing. So I didn't know if there was anything, out there
yeah, I'm
that,
not familiar. I think one potential avenue is actually building AI assistants, which often does take kind of more technical skill, but I believe OpenAI, at least for a while, as part of their paid subscription, you could build assistants using their model. It might be worth exploring, but I haven't done that, so it could also be an absolute disaster. I don't envy serials catalogers. That is a terrifying prospect to me.
I love it, unfortunately. But that's a great suggestion. I'll try and play around with it and see if I could come up with something.
I think that sounds like a great presentation for next year's conference.
Yeah. Thank you so much for your assistance.
Thank you.
Were there any other questions? We can probably take one more. We're a little bit over time, but if there is one more question. Doesn't look like it, but you've got a lot of great reviews there, Kevin, in the chat. So I guess that is it then for our presentation today. Thank you, Kevin, very much. And I hope that everybody enjoys the rest of the conference. Thanks for coming out.
Thanks so much, everybody, and thanks, Alicia.
No problem.